Okay, so we're going to prove that for every natural number n, that 1 cubed plus 2 cubed plus dot 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 plus n cubed is equal to n times n plus 1 over 2 squared. So let's go ahead and do this proof by principle of mathematical induction. So we're going to have our base step. So we're going to consider the statement involving 1. So that's saying that we're testing if 1 cubed is equal to 1 times 1 plus 1 over 2 squared. And, of course, 1 is equal to 1 cubed. So 1 times 2 is 2. 2 over 2 is 1. 1 squared is 1. So that definitely works for the statement involving 1. Let's see if it works for the statement involving 2. Right? So that's 1 cubed plus 2 cubed is equal to, so let's see, 2 times 2 plus 1 over 2 squared. All right, so 1 cubed is 1, 2 cubed is 8, 1 plus 8 is 9, and 2 times 3 is 6, 6 over 2 is 3, 3 squared is 9. So it works both for the first statement and the second statement. So now let's go ahead and do our induction step. So we're going to suppose the statement involving k is true for some k contained in the natural numbers. Of course, this implies that 1 cubed plus 2 cubed plus dot 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 plus k cubed is equal to k times k plus 1 over 2 and then squared. Right? So now we're going to consider 1 cubed plus 2 cubed plus dot 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 plus k cubed plus k plus 1 cubed. Because we want to prove, so assuming that it works for the statement involving k, so the sum of the first k terms is equal to this formula, we want to prove that the sum of the first k plus 1 terms is equal to the formula if we were to plug in k plus 1, right? So we know this is equal to, so we know this piece right here is equal to this formula because we assumed it. So this is equal to k times k plus 1 over 2 squared. And then, of course, plus the k plus 1 cubed. All right. So let's go ahead and write down what we want to get, right? So this, we got to get this to equal k plus 1 times k plus 1 plus 1 over 2 squared, right? Because that's the formula if we were to plug in k plus 1. So this is where we're starting, and this is where we want to get to. Okay, so let's see. We know this times itself is just, let me give myself a little bit more room. This times itself is equal to k squared times k plus 1 squared over 4. And to get this to have a common denominator with this term, we need to multiply top and bottom by 4. So that'll be 4 times k plus 1 cubed over 4. And then we can go ahead and combine these. So this will be k squared times k plus 1 squared plus 4 times k plus 1 cubed all over 4. Right? So both of these have 2k plus 1, right? 2k plus 1 terms. So I'm going to factor out k plus 1 squared. And then I'm going to be left with, so this will be k squared plus 4 times k plus 1. Right? And that's going to be all over 4. All right, so let me go ahead and scoot this one down a little bit to give myself a little bit more room. So now I'm going to actually move up this way and see if I can connect the two, right? So we know this is the same thing as k plus 1 times k plus 2 all over 2 squared. So I know I have that k plus 1 squared, right? A little bit more. So this is equal to k plus 1 squared times k plus 2 squared all over 4. So I have that k plus 1 squared. I got to see if k squared plus 4 times k plus 1 is the same thing as k plus 2 squared. So this is k plus 1 squared times k squared, and then plus 4k plus 4. And that's all over 4, right? But look, k times k is k squared, k times 2 is 2k, 2 times k is 2k, so 2k plus 2k is 4k, and then 2 times 2 is 4. So I know that this here is the same as this down here, and then I finished my proof, right? So this implies that S of k plus 1 is true. Therefore, by the principle of mathematical induction, for every n contained in the natural numbers, S of n is true. So we essentially proved that 1 cubed plus 2 cubed plus dot 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 plus n cubed is equal to n times n plus 1 over 2 squared for any n contained in the natural numbers, right? Because we're able to assume from our assumption that the formula, the sum of the first k terms is equal to this formula, we're able to show that the sum of the first k plus 1 terms is equal to the formula if I plug in k plus 1, right? By doing all this math here. And that is our proof.